All right, so this is 4-1. You know, we're going to do it in two parts, so we're going to call this Part A. And today we got 3 learning targets to distinguish statistical questions from other types of questions, identify the population and sample, and then next time we'll do the third target of what's an observational study versus an experiment. So here's one little example again. We did our anchored putter thingy-mobobber. Just going to kind of check this out. Tommy and Hannah go off campus to eat lunch every day. Because lunch period is short, they wonder if it would be faster to go inside their favorite fast food restaurant to use the drive-thru. Each day they flip a coin to determine the method. What a math geeky thing to do. They just flip a coin to see if they should go through the drive-thru or go inside. What they do is they collect the data. They record the total length of time it takes from the moment they enter the parking lot to the moment they receive their food. After several weeks of collecting that data, they analyze it and determine that ordering inside took about 2 minutes and 34 seconds less than going through the drive-thru. Here's their conclusion. It's faster to go inside. This is just an example of the statistical problem-solving process. So you'll see those 4 blanks on the top left of your little vocab part. These are the 4 things. Like I said, my slideshow is just a little different. So the 4 parts of a statistical solving process, if you'd write those in those blanks for 1, 2, 3, 4, the first thing you do is ask questions. The second thing you do is collect data. The third thing you do is analyze the data. And then the fourth thing you do is to interpret the results. That's the statistical problem-solving questions. Like Tommy and Hannah, they asked the question, which way is faster to get our food, drive-through or go inside? So what they did is they asked that question. Then they had to collect the data. It's like, all right, so they did it for a couple of weeks. Then they analyzed it, and they said, yeah, look at this. And they finally interpreted it. They said, going inside was faster. We do this statistical problem-solving process with a lot of stuff in life. You don't necessarily like write it all out, but anytime you've got a problem, you usually go through this 4-step process. So to ask a question, collect some data, analyze the data, interpret the results. Especially those guys that are into racing cars that I hear a lot about. You kind of do some experiments, you figure things out, you change some stuff, and then you analyze the results. So, all right, so here we go. What's a valid statistical question? It's based on data that vary. If you are asking a question, the way that is called a valid, this will be a lot of homework questions today, is if it's based on any kind of data that can vary. The answer to the question won't be the same each time as an observation is recorded. So let's do quite a few examples here. First question, they say, is this a valid statistical question? How much money Mr. Tagawa has in his wallet right now? So I don't know who Mr. Tagawa is, he's just a made-up dude. But if we asked him how much money is in his wallet at that moment, would that be able to vary? Or would it stay the same? How would it vary? Agree. Well, let's use me, for example, instead of Mr. Tagawa. Here it is. This is my wallet right now. There is money inside. Would you agree? Can it vary? Or is it just the same amount right now? Like just right now. I'm going to make it easy. Let's just pretend it's 20 bucks. 20 bucks. It doesn't vary. Would you agree with that? Because currently, at that moment in time, there's only $20 in my wallet. It's not like it's just, oh, here's another 3. Here's another 5 that shows up. Here's another 10. It's like there is a set amount of money right there. I know it's tough to understand, but that is not a valid statistical question because the answer can be answered with a single value that does not vary. It's not valid. The question can be answered with a single value that does not vary. What if we said how long students can hold their breath on average? Would that just be one number for sure, or when you ask students, would that vary? What do you think? Would it vary? That would totally vary. That means that that is a valid statistical question. Because especially the key phrase on average, you know, it's just like, okay, that means you've got a bunch of different answers. It's going to vary. So that means it's valid. If the answers can vary, that's a valid statistical question. What proportion of U.S. adults engage in vigorous exercise at least once a week? If you went up to an adult and asked them, Could that vary from another adult if you ask them? And you ask another adult, could it vary? Since it varies, what do you think? Valid or not valid? That is valid. You can shorten that up to say like answers will vary, you know, or the data varies. So you'd say valid, the data varies, if you want to shorten that up. So that's getting a little easier. Only 3 examples. Let's try 3 more. On average, how many days did students at your school play video games last week? If you asked one student how many hours they played, would that be exactly the same or could it vary from a second student? That could vary, right? So is it valid or not valid? Valid. Answers, data can vary. So just write valid, data can vary. Valid, data can vary. Are senior citizens more likely to choose vanilla over chocolate ice cream than teenagers? If you went and asked one senior citizen what they thought, would that be the same or vary than another senior citizen? Can the data vary? It varies, right? So that's valid. And then the last one, how many people in the United States were convicted of violent crimes last year? If you Googled that in 2022, how many people were convicted of violent crimes? If you Googled it once, and then you Googled it twice, and then you Googled it 3 times, would the data be the same or would it vary? It would be the same, right? So valid or not valid? Not valid. It's not a valid statistical question because the data doesn't vary. So, yeah, that first one's a little rough. Sometimes they're funny, you know, so we can talk it out when you're doing homework if you need a little help with that. So, all right, just 2 questions left, and we'll call it a day because we're splitting this into 2 parts. So the last thing is, like the first step of the statistical problem solving, asking questions. So you have to ask a good statistical question to do it. The rest is about, like, the second step for populations and samples. Suppose we wanted to find the percent of young drivers in the U.S. that text while driving, right? You know, it's just we want to find that information. To answer the question, we're going to survey every 16 to 20-year-olds who live in the United States and drive. Ideally, to get them all, you take what's called a census. We'll define it in a second. It's back up on the top where we're doing some of these. A census. A census takes every single person, but would you believe that that would be very hard to do, to find every single teenager, 16 to 20, in the U.S. and ask them? That's very hard to do. So what we do is we get a sample of those students, represent the entire population of young drivers. So let's define those 3 words. These are the 3 things that need to go in the blank. So where you have population up top in the definition boxes, it says it's a statistical study that is the entire. Please write the word entire into that blank up there on population. A population is a statistical study that is the entire group of individuals we want information about. It's like, who's the whole group you want info about? A census, if you go straight down, collects data from every individual in the population, so you just fill in that blank with every. And a sample is a subset of individuals in that population. So let's try a few and then see what goes on. Identify the population and the sample in each one. So the student government at a high school surveys 100 students at the school to get their opinions about a change to the bell schedule. Let's talk about the entire group of people they are concerned about. Is it the 100 students or all the students in the high school? Thoughts? Got one thought for it. The population is everybody, y'all. Everybody, right? So it's not everybody in the world, it's everybody at this high school. So please abbreviate it as POP for population. All students at that high school. All students at that high school. But who is the sample? How many students were actually surveyed? Tells us. How many students did they survey? 100. well, then that would be the entire population, and they would have done a census, you know. So, but I feel you on that. You don't have enough information, but apparently it's a large high school, you know. But that's a good question. So the sample is who got surveyed, and the population represents everybody. The bad part about it is on your homework today, it's very specific, right? So let's use the next one to talk about how specific it needs to get. A wildlife biologist in Alaska tranquilizes 42 grizzly bears in the state and records their weights and then releases them. What are we talking about? What group of individuals are we talking about? Bears, okay? It's going to be a multiple choice question on homework, and bears will be one of the choices possibly for population. Is it every bear in the world, like polar bears, panda bears, all that, or is it more specific than that? What kind of bears? Grizzly bears, right? Now, is it all the grizzly bears all over the world, or are they only in a specific state in this place? So that's why the population is all grizzly bears in Alaska. All grizzly bears in Alaska. You got to be specific with it, because that's who they were concerned about. Because the wildlife biologist is in Alaska. He tranquilized 42 grizzly bears in the state, records their weights, and releases them. The sample is the 42 grizzly bears tranquilized. The 42 grizzly bears. Sorry, much room to write this on the worksheet either. But the sample is just those 42 grizzly bears tranquilized. So there's two examples. Let's see if we can get a little better with it. Not that we're bad at it, you know. Let's see if we can get a little better at it. It's about being accurate. So the quality control manager at a bottling company selects 10 cans from production line every hour to see if the volume of soda is acceptable within limits. So would you believe they're talking about like soda cans, right? You know, like that's what they're talking about. What's the population? All the soda cans, but guess what? Every hour, you know, because they just did it in an hour's time. So this is a bottling company. They just got a little machine going with all these soda cans getting filled with soda. The population is all soda cans in that hour. I didn't even put it on here, sorry. At the company in that hour. Sorry about that. In that hour. You don't have to write every detail, but all soda cans in production that hour. The sample is usually pretty easy to tell. How many did they sample? 10. The 10 cans. The 10 cans. So I'll let you try the last one about Beyonce. That'll be our last one today. Like, can you figure out the population and what the sample would be? Give it a shot. The sample is usually pretty easy. Can we be down with the fact that the sample is the 15 Beyonce songs? Right? What do you want for the population, though? I'm glad you said that. She said all Beyonce songs. What if I just said every song in the world? You know, like would that be the population, or is it just the Beyonce songs in the world? Yeah, nice and specific. So all Beyonce songs are the population, and the sample is the 15 Beyonce songs. So I got a little shorty assignment for us. It's called 4-1 Part 1. I got to publish it still, and then we should be able to rock it.